So I have a little illustration to show you the difference between a tsunami and a seiche. Tsunamis occur when you displace the ocean floor. Essentially, if a fault goes up or down, it may displace the ocean floor, and then it throws the water into a column. That column collapses, and then it causes a wave to move on shore. So this is going to show you a dish, essentially, that's going to have a tsunami at one end, because I've displaced the ocean floor, and that ocean floor is represented by the saucer in this situation. And the idea behind a seiche is that a seiche is a sloshing of water in a confined area, so in a harbor or an inlet or someplace like that. They're very common also in earthquakes, but they're not caused by a displacement of the ocean floor. So tsunamis are really kind of devastating, as you probably already know, both from the 2004 and the 2011 tsunamis, which took many, many lives in the Indian Ocean and also in Japan. And the properties associated with this are the same in both situations, actually, in Indonesia and also in Japan. What you see in this illustration is the idea of what they call stick slip. If you have a subducting slab of ocean crust going underneath of, in this case, an island arc, there's a propensity to stick as it's being subducted. And so that capacity of being stick there allows it to build up a lot of stress. And then eventually it breaks. And so when it breaks, it actually causes rapid subduction of part of that. And the upper plate is then pushed upward, essentially. And so that's what you see in this illustration, where the overriding plate pushes upward, displaces ocean floor, and it generates a column of water above where that rupture occurred. And then that column collapses back down, and then you generate the tsunami wave. So that's the tsunamigenic sort of capacity that happens there. When you generate that wave, then it follows wherever it can go. And it goes at really rapid speed, right? So earthquakes happen almost instantaneously. And so tsunamis have a capacity to go almost 800 kilometers per hour. It's about as fast as a jetliner can fly. They're that rapid in the ocean, in the open ocean. So in the open ocean, you may not even recognize the tsunami when it passes you. It may be no more than a foot or two high. Now, at least a foot, maybe. And so, but what happens then when it gets onto a shoreline, that wave, which has an enormous amplitude, a low amplitude, and actually it's low frequency and a relatively high amplitude, I guess. But when it comes on shore, it begins to slow down. And when it slows down, it begins to pile up then. And so that's what happens is the water comes in a surge, essentially, that just keeps on going. And so that happens when it slows down and it comes on shore. So the speed decreases as it hits a shoreline, typically. And then also it just causes a massive influx of a volume of water. In this next image, you can actually see the capacity for these things to also, have a really high velocity. 835 kilometers per hour is what it says here, where you have a displacement of the ocean floor. But it gets down to 50 kilometers per hour once you get on shore then. So when the water depth gets much, much lower, things pile up and it comes ashore. They call that a run-up, actually. And so you get a run-up of the water. And then, of course, there's the flow backwards. Very commonly with tsunamis, the waves are not as closely spaced as what you see in this diagram. In fact, it may be 45 minutes. It may be 20 minutes. It all depends on the volume of water that was generated. But that water comes ashore, and it may be several minutes before it happens. The other phenomena here that they don't mention in this is that you commonly have, you can actually have a displacement downward in the ocean floor. And if that occurs, it actually can draw the water out originally. And so in Hawaii, in places that are in the middle of the the Pacific Ocean, for instance, when it is very common in Hawaii, actually, for the water to draw out of the bays. And if you see that, it means run uphill. So oftentimes people in the past would go down and pick up fish and things like that for the evening meal or whatever. And that's exactly when you should turn the other way and run uphill. In Hawaii, they actually have two words for it. It's I can't remember one of the words, but one of them is makai. And so you either go uphill or you go downhill down to the water. And so that's pretty important, I guess. So it can behave either way. So if you happen to be at a resort somewhere on a beach and all of a sudden you see the water pull out, you better go look for high ground immediately, seriously, because it's coming. Within 20 minutes, it will be there. So that is the idea of a tsunami. This is actually an image of what it looks like with when you have a tsunami, and Hawaii is particularly susceptible to tsunamis. And so this image was actually taken in the 1940s. I think there was a very famous tsunami in Hilo, Hawaii in 1948. Now, a lot of people think that the guy that's in this photograph, this is probably photoshopped, but in fact, the rest of it is actually real. And so the wave came on shore and destroyed a lot of the harbor in Hilo. Hilo's especially susceptible for these sort of phenomena, these sort of waves. And so Hilo had one in 1960 associated with the Chilean earthquake. I think there was a smaller one in 1964 with the Good Friday earthquake that was in Alaska. But they've had these over millennia, okay, or well, they haven't been there for millennia, but they've had it over the centuries. That they recognize that tsunamis are a phenomena that's very common in Hawaii. So here you see in Japan, which is also susceptible to tsunamis, and in fact, they originated the word for this, right? It originally means harbor wave, and so the tsunamis have caused a lot of damage in the past in Japan. And so this is a much earlier tsunami than the 2011, obviously, here. But any place that's coastal is susceptible for having tsunamis, and even places you wouldn't suspect. So, for instance, even Florida is susceptible to tsunamis. And the rationale behind that is you could actually have a massive landslide, a submarine landslide off of the Canary Islands that could actually pretty much inundate much of Florida. And so the idea is that these are phenomena that occur much more regularly than we give them credit for. And so we've only recorded earthquakes since the early 1900s, and tsunamis, there's records, of course, in a few places around the world, but there have even been tsunamis, for instance, on the east coast of Britain associated with the North Sea. And so here you can see a couple of photographers running away from this tsunami, and you can see a slight inflow. And I don't know exactly where this photograph was taken. I'm pretty sure it was on the Indian Ocean, but not exactly sure. But that is a tsunami, and you can actually see the run up here. And so it may not be very, very high water to begin with, but it builds and it builds and it builds. It's like rising sea level almost. And in fact, that's what it is. And so the rising water is dangerous because it knocks down buildings, and then you have all that debris that's flowing with it as well. That was one of the common things that you would see, for instance, in the Indonesian, the Banda Aceh tsunami, the Banda Aceh earthquake, and the tsunami that followed around the perimeter of the Indian Ocean. It hit Thailand, it hit the Andaman Islands, it hit Sri Lanka, and it hit even on the coast of Africa. And so by the time that they knew that there was a tsunami, there was no tsunami warning system in the Indian Ocean. But now, with the idea that they heard reports from Sri Lanka and other places, the word got out through the American embassy. It's like you need to make phone calls down to the harbor areas on the east coast of Africa, and they saved some lives that way. There were actually 2 people killed in Africa from the 2004 tsunami that hit. Well, that was generated from the Banda Aceh earthquake. Let me show you some images, and I don't want to dwell on these too much. I have uploaded one link from National Geographic that shows the 2011 tsunami in the Sendai province, the Tohoku earthquake. So you can go to that link and see, 3 minutes of tsunami damage and a short explanation from the folks at National Geographic. But here are some aerial images of Banda Aceh. This is before the earthquake, and so this is a satellite image looking down on the village of the city of Banda Aceh in the north of Sumatra. So, Sumatra is one of the northern islands in Indonesia, and this area was very prosperous. Fishermen and so forth were out to sea that day. The earthquake struck, and then I think it was about 15 minutes later that the tsunami came ashore. And estimates are that it was about 50 feet high when it hit Banda Aceh. And so there are buildings that have some of the panels stripped off of them up 50 feet in the air. Some concrete buildings that survived, but the siding didn't, so the structure itself is there. And so you can tell how high it came on that building, and then you can also see what it did on the shoreline where it stripped vegetation off. So almost 50 feet high in places right near the epicenter for that earthquake. So that's Banda Aceh before. Here's Banda Aceh afterwards, and you get the idea. It's these are devastating sorts of things, and there were 250,000 people killed in that tsunami, mostly in Indonesia and Thailand and places around the perimeter, and Sri Lanka, around in closer proximity to the earthquake. So that's in Indonesia. Here's an image. You can actually see some of the phenomena of how the waves interact with one another. So as water has inundated this city, and that's the brown areas on the right-hand side, that water flows back out then, and it interacts with some of the other waves that were coming in at one point. So this is an image from Sri Lanka. Now, I've heard some accounts of the tsunami coming into Sri Lanka. There was a young man who was riding a train with his father, and the train was actually pushed off of the track, and people were trapped in the train and had to find a way out to be able to scramble to get up to the top of the train and stand on the top of the train. It was the only place above water, essentially. If you were in the train, you would have drowned. So it's a sad tragedy, but it's a natural sort of phenomena, and that's why we talk about it in here. It is a phenomena that strikes the coastlines around the entire world pretty much. So there are areas that are more susceptible than others, but at the same time, these are the sorts of things that happen in coastal areas. Now, in Missouri, we don't have to worry about that too much, but I have to tell you, there is a record of a tsunami even in Missouri. Now, this was a time when sea levels were higher, but in the boot heel of Missouri, and you may recall what I talked about, the New Madrid fault zone, that fault zone wasn't responsible for that tsunami. The ocean used to come all the way up what today is the Mississippi River Valley, all the way into Missouri. And about 65.5 million years ago, a meteorite struck in Mexico on the Yucatan Peninsula, that peninsula that sticks out into the Gulf of Mexico. And from that impact, there was a tsunami that actually rushed ashore in the boot heel of Missouri. And it's preserved in some of the Cretaceous age rocks there, the Cretaceous Paleogene succession that's exposed in place in Crowley's Ridge, actually. And there's a geologist, who studies this sort of thing. She's at she's at MS&T, Missouri Science and Technology, Missouri University of Science and Technology. But she studies these sort of things along with Carl Campbell. He's with the St. Louis Community College system. And so, yeah, there's a record of meteorite impacts, even here in Missouri, and tsunamis associated with an impact. Well, okay, so if we talk about tsunamis, the real tragedy, of course, is how it affects humans. If it were just a tsunami that didn't affect anything, you could stand back as an observer and watch the thing in awe at the sheer majesty of of natural forces at work, but in fact, people are affected by tsunamis now. They weren't back in the Cretaceous Paleogene, although our ancestor species were back then. There are persons that you see here that have survived that tsunami, and so it's always good to survive these sort of catastrophes. I think we're going to leave it at that. And so this is the presentation on tsunamis. Tsunamis are a byproduct of several processes, as you now know. That can be meteorite impacts. It could be a submarine landslide. You've seen those from the volcanics in Hawaii. Those things would generate tsunamis as well. You know that also earthquakes can generate tsunamis. And then let's see, there was one other one here, right? So there's submarine landslides. Well, anything that's going to displace the ocean floor, essentially, or displace the water in the ocean can generate a tsunami. Anyway, that's it for now. So thanks, and this will get put up today, and then I'll start on the earthquake processes next. They're a little out of sequence here, but I'll get it up, and I feel a little bit better now, so hopefully we'll get moving on with this. And so we'll have a quiz on Friday covering this material, earthquakes, and the earthquake disaster, to the two presentations on that. And then also we'll have an exam on the 15th. And so the 15th on not this coming Friday, but the following Friday, you'll have an exam. It's exam number 3. So anyway, I'll call it there. Thanks a lot for your attention, and thanks for tuning in. We'll talk to you later. Bye now.